Hey guys, so we're changing gears from algebra to geometry, and today we're doing 4.1 triangles and angles. Today you're going to be doing 4.1 and 9.2, so after you finish this video, make sure you watch the 9.2 video as well. So when we talk about classifying triangles, we can either classify them by their sides or their angles. So let's start by looking at how we classify triangles with their sides. So in this first triangle, what you can notice is that we have 3 congruent sides. That's what those little lines mean. So all their sides are equivalent. So when we have exactly 3 congruent sides, that means we have an equilateral triangle. In the second triangle, we have 2 congruent sides. And that means we have an isosceles triangle. Finally, our last triangle, we don't have any congruent sides. And so for these triangles, we call them scalene. Now I want to mention that with an isosceles triangle, when we say it has 2 congruent sides, we mean it has at least 2 congruent sides. So for instance, our first triangle had 3 congruent sides, so that's at least 2. So any equilateral triangle can also be categorized as an isosceles triangle since it has at least 2 congruent sides. However, with an equilateral triangle, it has to have exactly 3 congruent sides. So an isosceles triangle is not an equilateral triangle. So it works one way, but not the other. We can also categorize triangles by their angles. So in this first triangle, I noticed that every angle looks to be less than 90 degrees. And when something's less than 90 degrees, we call it acute. I kind of remember that as it has some cute angles. Maybe that's a silly way to remember it, but it works for me. So we call this an acute triangle because all its angles are less than 90 degrees. The second triangle, you can see that because of these little pink marks, that tells us that all our angles are congruent. All angles congruent. So that means, again, we have an equilateral triangle. So we can tell a triangle is equilateral whether it has 3 equal sides or 3 equal angles. Either way, we'll know it's equilateral. In this third triangle, you can see we have a right angle, which is marked by this little box in the corner, which means that we have a 90-degree angle. And so we could classify this triangle as a right triangle. Finally, this last triangle, if you notice its angles, this guy looks to be more than 90 because a 90-degree angle would be more box-like, like this guy. So if we have an obtuse angle, which means we have an angle greater than 90 degrees, then we have an obtuse triangle. So that's how we can categorize triangles according to their sides or their angles. So a little bit of vocabulary with our triangles. So if we're talking about a right triangle, like in this first one, since we have one right angle, what we can do is call the side across from the right angle, we call this the hypotenuse. And then our other sides, the ones that are not our hypotenuse, we refer to as our legs. If we have an isosceles triangle, since we don't have a right angle, we don't have a hypotenuse, but what we can do is call our sides that are congruent to each other, we call these our legs, and we call the side that's not congruent our base. So let's look at some examples where we classify our triangles. So in the first one, we're not given a whole lot of information. The only information that we're given is this little box here. And remember, that tells us that we have a right angle. So we could classify this triangle as a right triangle. For the second one, we can see that we have congruent sides because there are little pink lines here, but we can also see that we have 2 congruent angles of 80 degrees. So we can either use angles or sides to classify this one, but either way, we can see that it's an isosceles triangle. Go ahead and see if you can classify the other 2 on your own. So for the third triangle, we have one angle that's 200 degrees. Now remember, if we have an angle greater than 90 degrees, which 200 degrees is definitely greater than 90 degrees, we can classify this as an obtuse triangle. Alright, last but not least, we have a triangle that has 3 congruent angles. They're all 60 degrees. So since they're all the same, that means we have an equilateral triangle. We're going to do a couple more examples. We're asked to find the measure of the missing angle. So remember, in a triangle, our angles add up to 180 degrees. So in our first triangle, we're given that one angle is 36 degrees, we're given that one angle is right, and then we have to find this third angle, we call it x. So we know that if we add all our angles together, it should give us 180 degrees. So let's add them together. We take 36 degrees plus our right angle, which we know is 90 degrees, plus x. That should all equal 180 degrees. So now all we have to do is simplify and solve for x, just like we did in our first lesson during summer school. So 36 plus 90 is going to be 126 degrees plus x degrees. So we have x plus 126, so we have to do inverse operations. So the opposite of adding 126 would be subtracting 126. So x would be 54 degrees. And then we can just check and make sure this works by adding all our angles back together, just to make sure that they equal 180. Our x was 54. We had 36 to begin with, and 90. So 54 plus 36 plus 90 is in fact 180 degrees. In the second triangle, we have 40 degrees, and then we have our base angles are x degrees. So we can classify this triangle. We know that since we have 2 congruent sides and 2 congruent base angles, that we have an isosceles triangle. That's pretty helpful because now what we can do is the same idea. We want to make sure that all our angles added together is 180. So if we took 40 degrees and we added x degrees and then our other angle of x degrees, this should give us 180 degrees. Well, since x and x are like terms, and we know that there's a 1 implied in front of both of these x's, we can add like terms, and this would become 2x degrees equals 180. Now all we have to do is solve for x. We just do inverse operations. So we have plus 40, so the opposite of that would be minus 40, minus 40. So we have 2x is 140, and then we have times 2. The opposite of multiplying by 2 would be dividing by 2. So we would get 70 degrees. So both of these base angles would be 70 degrees. And again, we can check this by adding together all our angles that we know. So we have 40 plus 70 plus 70, which indeed is 180. So we're good. All right, that's it for triangles and angles. Next, we're going to do 9.2. Make sure you watch it because we're doing it all in one day today.